end of World War II, space has been the last frontier. But in the beginning, it wasn't pretty. How did we get from this to this?
0. Liftoff of the Falcon 9.
Stage 1 propulsion is nominal.
And this.
Our drone ship, waiting for here's the engine. Slow it down, lights are deployed.
Well, it all started with the space race in the 1960s. The first artificial satellite that was launched was by the Soviets on October 4th, 1957, and the first U.S. satellite launch was in 1958 by NASA and the U.S. military. Kennedy was a big player in the space race, politics, and just like helping out. He gave a challenge to NASA to put a man on the moon, and by doing this, he also asked for Congress to approve $7 to $9 billion of funds in the next 5 years to go to NASA. And the quote that Kennedy said was, "I believe that this nation should commit itself to achieving the goals before this decade is out. Landing a man on the moon and returning him safely to Earth. No single space project will be more exciting or more impressive to mankind, or more important. None will be so difficult or expensive to accomplish." When NASA and Russia finally were able to cooperate, they were able to cooperate on 3 things. To exchange weather data and satellites and eventual coordinated launching of meteorological satellites, a joint effort to map the geomagnetic fields of Earth, and the cooperation in the experimental relay of communications only after the U.S. launched a man into space. And then came the 3 programs: Mercury, Gemini, and Apollo. Mercury is the first one, and it started in 1958, and the main goal of Mercury was to put a man into space. Gemini was the second program, and that was to put a man into space and then also into orbit. And third, Apollo was to put a man into space and then onto the moon. NASA's next endeavor was the Space Shuttle program, a mission to launch large vehicles into space and recover them on the ground. It started in 1972, and the first flight occurred in 1981. Space shuttles flew through 2011 and were used to help assemble the International Space Station. However, the program was criticized for its poor oversight and large cost overruns. One of the large issues during the Space Shuttle program was the Challenger disaster, which occurred in January of 1986. It was a cold morning, and the engineer said it was too cold to launch, but the people at NASA were concerned about missing another launch date, so they decided to fly anyway. The cold messed up one of the solid rocket boosters of the Space Shuttle, and it ended up exploding partway through the flight, killing all 7 aboard. This stopped the Space Shuttle program for the next 2.5 years, while design changes were made. During the Space Shuttle program, NASA also built the International Space Station in conjunction with Russia. It is currently being used as a floating laboratory orbiting the Earth. However, there is a problem because NASA doesn't currently have a rocket that can be used to transport people to the International Space Station. We must rely on the Russians to bring all of our people to the International Space Station, as well as much of our cargo. This is changing, however, as NASA uses commercial transports through U.S. companies, including SpaceX and Orbital Sciences. James Webb is supposed to be the successor and the upgrade to the Hubble telescope. It is being developed by NASA and was named after the former secretary of NASA, which pretty much got NASA rolling in the space industry. The James Webb is very different than the Hubble telescope. The James Webb has infrared capabilities, while the Hubble telescope is primarily optical. The James Webb's primary goals are to search for galaxies, the first galaxies or luminous objects that formed after the Big Bang, and determine how galaxies evolved from their formation until the present, and observe the formation of stars from the first stages of formation of the planetary systems. Measure the physical and chemical properties of planetary systems and investigate the potential life in those systems. The James Webb is going to be launched on a European rocket, which shows how far behind the US's rocket capabilities are. This is a very big problem because also the U.S. is very hesitant of giving out contracts to private companies. They only give it out to the ULA because people who worked at the ULA also used to work for NASA, so there is some shady dealings.
So NASA's current main development is the Space Launch System, or the SLS. It's going to be NASA's next generation rocket, much larger than any ever built before. Its goal is to get people to Mars, but it's not going to be able to do it alone. There will have to be some intermediate between Earth and Mars for the 7-month journey. It's also a very expensive project, costing about $41 billion over the term of its life. And there's only 4 launches forecast, so you're not getting a very good return on your investment there. Additionally, it's only going to be able to launch every 4 years, so if you want to be able to put supplies on Mars and people on Mars, if there was some emergency and they needed to send more supplies, it would be 4 years out, which is much too long. Another problem the SLS faces is its aging technology. The engines were designed for the Space Shuttle program, and many of them were actually built 30 years ago. So in 16 years, when the Space Launch System is actually launching, the engines will be 45 or 46 years old, which raises serious questions about their reliability. So NASA has yet to come up with a solution to this problem. Also, the full thrust variant won't be available until much later into the 2030s, so there won't be the full lift capability until after then.
NASA is planning on sending people to Mars. They have a launch date of sometime in 2030. This is highly improbable to happen with NASA's funding and development power. They have no foresight on having a trans-Mars space station, which would be a satellite that would be placed between Mars and Earth because of the travel length of going from Earth to Mars, which is a 7-month-long journey, and this trans-Mars space station would help keep people alive and resupply on the journey to Mars and back.
So the future of space travel really lies in commercial private companies bringing cargo and people into space. The major player here is SpaceX, which is a company that was founded by Elon Musk of Tesla, among other things, in 2002. His vision for the future is to bring space travel to everyone cheaply and with the end goal of enabling people to live on other planets. So he saw the inefficiency at NASA. They would subcontract all their work out to other companies who would then subcontract their work out to smaller companies still. So you'd have people buying the metal, and then people rolling the metal, and then people assembling the metal, and then NASA buying all the parts. And he saw how much overhead and how much cost there was associated with this. So he started his own company where they make almost all of their parts in-house in order to control quality and to keep costs low. For a bottom line, their launch costs per launch are between $62 and $90 million, and the United Launch Alliance, the ULA, their launch costs per flight are between $225 and $460 million per flight. So SpaceX has been able to deliver a similar service at a much lower cost. Another way SpaceX is innovating is with reusability. NASA tried this with the Space Shuttle, but the cost of refurbishing all the engines and everything after each landing became so high that it was very inefficient and they eventually abandoned it. So what SpaceX is doing is after the first stage burns out, on normal rockets it just drops into the ocean and it explodes. But what they do is they turn the stage around and they burn the main engines again to slow it down so that once it re-enters the Earth's atmosphere it's going slow enough that it can land on a barge in the ocean vertically and then be recovered and reused. Sometimes if they have the fuel they bring it back to the main landing site and use it there, but the end goal is to save as much money and as much of the launch cost as possible. Blue Origin is another relatively new space company. They are designing rockets that can carry people into space, not into orbit like SpaceX, but into space for tourism and small experiments. They're also experimenting with reusability, recovering the booster and the payload section both. So commercial spaceflight allows for private companies to really further technology, and the competition in the marketplace means technology will advance better at a quicker rate and at lower costs, which will help to bring spaceflight to more people and to enable more people to put satellites into orbit and to do science and to advance the human race. Additionally, it creates a lot of jobs that wouldn't be there with a government-sponsored space program. So it's really going to be the future of spaceflight over the next few years.